Effect of additional cadmium chloride additives to saturating mixture on the formation of diffusion titanium layer on steel and cast iron. Abstract. In this work, the influence of the saturating mixture composition on the processes of the surface diffusion layer formation on gray cast iron and steel is investigated. Microstructural studies of the surface layer on gray cast iron and steel obtained using saturating mixtures of different composition were carried out. According to the method of the experiment simplex-lattice planning, mathematical models were obtained that reflect the dependence of the diffusion layer depth, corrosion resistance, rate of oxidation on the saturating mixture composition. Studies have shown that the optimal amount of cadmium chloride in the saturating mixture for the diffusion titanization is 610%. Based on the obtained diagrams property composition of the mixture analysis, the new saturating mixture for titanization of steel and cast iron that provides effective increase of diffusion covering properties is developed. Keywords: gray cast iron, steel, diffusion saturation, titanization, cadmium chloride, microstructure, diffusion layer depth, corrosion resistance. Introduction. One of the types of providing special properties to the surface layer of steels and alloys is the diffusion saturation with various alloying elements. The surface layer will acquire the appropriate level of properties. Diffusion doping of the surface allows to achieve the absolute layer continuity and a high alloying elements concentration in the surface layer, which is especially important for the protection of cast products in aggressive environments 1 to 4. The process of diffusion saturation does not require special equipment and can be carried out in any heating furnace with an operating temperature of 1000-1200. According to the literature, ammonium halides, mainly ammonium chloride, are most often used as activators in diffusion metallization 5 to 7. This study is devoted to the development of methods to increase the saturating mixture's efficiency for diffusion metallization of low-carbon steel St3 and gray cast iron in order to increase their corrosion resistance and oxidation resistance. Preliminary studies of the structure and properties of diffusion layers obtained in different mixtures at saturation temperatures of 900-1050 degrees C and holding time of 28 hours showed that the saturation temperature of 1000 degrees C and holding time of 6 hours are optimal. The study of the additional additives' influence on the diffusion coating's properties was performed using the methods of experiment mathematical planning. The choice of the saturating mixture composition is a difficult task because the elements that are part of it have different intrinsic diffusion coefficients, as well as the mutual influence on the diffusion rate. There may be cases when in the presence of additional additives at a certain content of saturating elements in the working mixture, the depth of diffusion and concentration in the surface layer of one or both elements is significantly reduced compared to one component saturation 9. The diffusion layer properties can be significantly improved by obtaining on the complex doped layer surface. Thus, the positive effect of Al and CDCl additives in the saturating mixture is explained by the fact that these elements form on the diffusion layer surface quite dense and strong oxide coatings, which increases corrosion resistance and the diffusion layer's stability, because of the diffusion rate decrease of the coating elements into the base metal, or by creating barrier layers at the boundary of the coating the base metal 10. Existing data 5 to 7, 11 suggest that titanium, as a strong carbide-forming element, combines much faster with carbon than with iron. Therefore, at the initial moment of saturation as a result of titanium diffusion with a saturating mixture, titanium carbide TiS is formed on the surface. The formation of titanium carbide is accompanied by intense diffusion of carbon to the surface, which leads to a sharp redistribution of carbon. At the same time its concentration increases in a surface zone due to association of near-surface layers, forming a decarburized layer. At the next stage, the diffusion flux of carbon to the surface decreases, first, due to the presence of a decarbonized zone under the layer, secondly, due to the decrease in the diffusion mobility of carbon in titanium carbide. Further growth of the diffusion layer is due to the diffusion of iron and titanium in the surface layer, which leads to the formation of compounds FeTi and Fe2Ti, according to the FeTi diagram. The main research material. Previous studies 8 have shown that ammonium chloride is the most acceptable among the tested activators for the titanization process. It allows to obtain on low-carbon steels layers with a high content of titanium, which is consistent with the data of 6, 12, and on cast iron a titanium carbide with a narrow zone of solid solution. Obtaining a soft sublayer is a positive factor when using carbide layers that work on wear. However, the small thickness of the titanium carbide layer and the strong increase in its brittleness with increasing thickness does not allow the use of titanium surroundings with ammonium chloride for effective saturation of cast iron. In order to eliminate this disadvantage, a titanium mixture containing cadmium chloride and combining cadmium and titanium was developed. This process was carried out in mixtures of different composition. The mixture's composition, as well as the results of the layers properties study, are presented in Table 1.